This is Subhro sir from Calcutta. After a very long time, I'm making my video because of my broken tripod. After my videos on probability, some of you emailed me to make videos on statistics. So today I'm intending to start this vast portion of mathematics. Since statistics is involved with plenty of theories and mathematical orientations, so my target is to build the summarization of the whole and teach you part by part in my consecutive videos. So keep watching, and today I'll discuss about the introductory part of statistics, grouping and displaying of data. So let's get started. First of all, we have to know the origin of statistics. The word static comes from the Italian word statista, which means the statesman. It was first used by Gottfried Aschenwald, a former professor of Marlborough and Göttingen University. Then after that, in the 18th century, Dr. Zimmermann introduced the word statistics into England. Its use was popularized by Sir John Sinclair in his article Statistical Account of Scotland within the years 1791 to 1799. So actually we can say that long before the 18th century, people were recording and using data. The question is what a data is. Data are nothing but the collection of any number of related observations. We can collect any type of data like the number of phone calls per day or the number of phone calls monthly or yearly. Now, after collecting all the data, this collection is known as data set. Remember it, this collection is said to be a data set, and a single observation is known as data point. Now we will proceed towards how we can arrange the data. But before that, I want to let you know that statistics has two subdivisions. The first one is descriptive statistics and the second one is inferential statistics. Suppose a professor computes an average grade for one mathematics class. Since statistics describes the performance of that one class but not make a generalization of several classes, we can say that the professor is using descriptive statistics. Also, the graphs, charts and tables to make a data set easier to understand are actually descriptive statistics, and as they are describing the display of data set. Again, suppose the professor decides to use all the average grades achieved by one mathematics class to estimate the average grade achieved in all 10 sections of the same mathematics class. The process of estimating this average grade is a problem in inferential statistics. It is also known as statistical inference. Now the methods and techniques of statistical inference can also be used in a branch of statistics called decision theory, which is very useful for business management as it is used to make decisions under uncertain conditions. For example, we can say that the statisticians can say the longevity of an LED light or mileage of a car, etc. by the decision theory. So it's a very important portion of statistics. The question arises that how can we collect and arrange the data set? It's actually has some simple steps. First of all, statisticians select their observations so that all relevant groups who are working to make a particular data set are represented in the data. Now, these data can come from actual observations or from the previous records. These data now are arranged in a particular manner, and then the decision makers guess the probable effects or characteristics of the data, or we can say the characteristics of data set. So these are the steps followed by the collection or arrange a particular data set. After that, these arranged data are tested whether they are relevant to our target, and then we can come to a logical conclusion. Now we will learn how to find a meaningful pattern in the data. There are many ways to sort data. We can simply collect them and keep them in order, either in ascending order or in descending order. But if the observations are in numeric, we can list the data points in ascending or descending, whichever is required. But if the data are skilled workers such as carpenter, iron makers, iron workers, etc., or if the data are various colors of sweaters manufactured by a particular firm, then we have to organize these data in a different way. We must present the data points in alphabetical order or by some other organizing principle. So basically we have to organize data by dividing into similar categories or classes, or categories can be said as classes in statistics, and then count the number of observations that fall into each category or class. This method produces a frequency distribution. I'll describe frequency distribution later. Keep watching. You can ask one question: what is the reason behind arranging a data or a data set? The purpose of organizing data is to enable us to see quickly some of the characteristics of the data we have collected. We look here for things such as range, apparent patterns, etc. to know which value appears most, which data point is presented for least number of times, and so on, etc. The more data we collect, our outcomes become more stronger, and the better result we can make, and the better decision we can make. Now, we have to know one very important thing named data array. The data array is nothing but one of the simplest ways to present a data or a data set. It arranges the values in ascending or descending order, whichever is required. The advantages of the data array are that we quickly notice the lowest and highest value in the data. We can easily divide the data into sections. We can see whether any value appears more than once in the data array or not. And furthermore, we can observe the distance between the succeeding values in the data set. But for the large quantity of data, this array becomes very difficult to list. You can say it's a disadvantage of data array. So it's the only disadvantage of data array actually. There is one better way to compress data, which is frequency table or frequency distribution. Now the question arises here, what the difference between frequency distribution and data array? So we have to look at an example. Let's have an example. For the average average inventory of 20 convenience stores. In the table 1 and 2, we have taken identical data concerning the average inventory and displayed them first as an array in ascending order and then as a frequency distribution. To obtain table 2, we had to divide the data in groups of similar values. Then we recorded the number of data points that fell into each group. Here we can observe that we have lost some information in constructing the frequency distribution. For example, in the table 2, we cannot clarify that the value 5.5 appears 4 times or 5.1 doesn't appear at all. But we can gain information concerning the pattern of average inventories, which was my target actually. To define frequency distribution, we can say that a frequency distribution is a table that organizes data into classes or groups of values describing an identical characteristic of the data set. In the example I gave, the average inventory is one characteristic of 20 convenience stores. Also in the table 2, in the column name class, we have an upper class interval and a lower class interval in each class. These are called the class intervals, and the width or length of the class interval can be calculated by difference between the upper class interval and lower class interval. Now we can also construct graph using frequency distribution tables. Now there are various type of graphs. First of all, we have to know how to arrange a frequency distribution and what is cumulative frequency. Here we can see that the class interval is 15.2 to 15.4, 15.5 to 15.7, 15.8 to 16, 16.1 to 16.3, 16.4 to 16.6, and finally 16.7 to 16.9. And the frequencies are, the respective frequencies are 0.07 for this first class interval. For the second class interval, its frequency is 0.17. Similarly, the third one 0.37, 0.20, 0.10, and finally 0.10. Now, what is cumulative frequency? Cumulative frequency means the first frequency is equal to cumulative frequency, and the second cumulative frequency means the first cumulative frequency plus the second frequency. That means 0.07 plus 0.17, which is equal to 0.24. And third cumulative frequency is equal to second cumulative frequency, that means 0.24 plus third frequency, that is 0.37, which becomes 0.61. Similarly, the next one is 0.61 plus 0.20, which becomes 0.81. Next one is 0.81 plus 0.10, 0.91. And the last one is 0.91 plus 0.10, which becomes 1.01. Now we will discuss about the histogram. What a histogram is? A histogram that uses the relative frequency of data points in each of the classes rather than the actual number of points is called relative frequency histogram. The relative frequency histogram has the same shape as an absolute frequency histogram made from the same dataset. Now, what is histogram? We have to show in graph. So let's have a look to the graph. Picture showed on board is the picture of histogram. Is a graphical representation of histogram. Here in the x-axis I have shown the class intervals 15.2 to 15.4, 15.5 to 15.7, and like this last one is 16.6 to 16.8. And in the y-axis I have shown the frequencies 0.10, 0.20, 0.30 and upward. Now from 15.2 to 15.4 its frequency was 0.07. That's why it's from here to here, and we have joined this one also. And for the class interval 15.5 to 15.7 its frequency was 0.17, so it's up to here, just below 0.20. And the highest frequency was 15.8 to 16.0, its frequency was 0.37, so it's above 0.30 and below 0.40. And this one is 0.20 and these two are 0.10. So we have to make this frequency graph in a graph paper I've shown on board. So please practice this on this histogram on graph papers. Now we will discuss the frequency polygons. Although less widely used, but frequency polygons are another way to portray graphically both simple and relative frequency distributions. To construct a frequency polygon, we mark the frequencies on the vertical axis and the values of the variables we are measuring on the horizontal axis, as we did with the histograms. So look at the board. We have marked the midpoints of the class intervals. 15.2 to 15.4, the midpoint is 15.3. How to calculate the midpoint? This is another way to calculate the midpoints. Just add these two and divide it by 2. That means 15.2 plus 15.4, which is 30.6, and divided by 2 becomes 15.3. Similarly, we can find the next midpoints. So these are 15.6, 15.9, 16.2, 16.5 and finally 16.8. And Now see, the points are in the difference of 0.3. So 15.3, and before that we can find the previous point, which is 15.0, and in the last, after 16.8, we can find the last point, 17.1. Now we have to join these points, and after joining these points in a in the graph, we can find the frequency polygon. Similarly, we can make ogive graphs. A cumulative frequency distribution enables us to see how many observations lie above or below certain values, rather than merely recording the number of items within intervals. So we can make the an ogive graph by making the frequency table and the cumulative frequency table. Sorry. So look at the board. Here we have pointed the cumulative frequencies which we have got from the previous table, and joined in this graph simply. So first of all, we have to point out those cumulative frequency points, and then we have to join these points. Then we can make an ogive graph. My video is over today. Thanks for watching, and keep watching my videos on my channel. Please subscribe if not done yet, and like this video and share with all. So thank you.